Right. Okay. So last week under chemical calculations, now we saw how to see ppm. Today we'll see if they give a ppm. Last week we discussed about ppm. Today we'll see if they give the ppm. Last week also we did a question related to ppm. Now today also we'll see if they give the ppm, how to find the concentration. Last week we did know that one. How to find concentration when they give the ppm. So today also we'll see when they give a ppm, how to see the dissolved amount. Oh, we'll see how to find a ppm. The comma we'll see today. Right. Now, guys, in this, we'll say a substance is there. Substance called A. This A dissolved 0.002 moles in this solution. In a solution. This is a solution. Some solution. A person name will think A is dissolved 0.002 moles. They have given A's molar mass, capital MA. Molar mass A is, they have given 20. Okay, 20 kilo they have given. Capital MA is 20. It means molar mass of A is 20. They have given the amount of solution in this. It is 250 cubic centimeter. Now they are asking for the ppm of A. Find ppm of A. Because when you see this now, later part, you won't get scared for these things. ppm and all, right? Hurry. Now parts per million. What do you mean by parts per million? What is the equivalent unit for parts per million? Taggala, the students who were present last week, Taggala, reply me, guys. Parts per million equal to? It means there should be some meaning, no, guys. If you have participated last week, I think you should tell the answer. No? ppm is equal to? What is the equivalent unit for ppm? I gave a unit for ppm. No? What is the unit I gave for ppm? Yes? Yes. What? Milligram per decimeter cube. Right? That is only ppm. Pota, remember me. Remember, if you participate these things without writing these and without recalling this, no use. Because in this what we give, why are we giving this? With a complete use is when you participate this properly with 100% things. Again, whenever you participate, you have to recall the things and you have to come to the next night. The chutti half an hour sessions with it we are doing we are putting small chutta we are putting. I think if you can't do these things, what will happen? You will face problems. I think it will be a continuation, nice series. Like, so you have to complete these notes and come. Right? Again, whoever watching these guys, please complete the notes because one night, half an hour mean 1, 2, 3, 4, 5, 6 kila when it's going, it will go for how many hours? 3 hours. 6 night when I go to 3 hours. 7 mean 3.5. Either it will increase the hours. So please complete this as a proper note, then you can finish a big part of the chemical calculation. Big part of chemical calculation, the basic parts, again, important parts you can complete. So please do this properly. Okay? Right. Now, Buddha, now find ppm of N. So A mean ppm, I give equivalent unit milligram per decimeter cube. Right. So what can I do? First of all, using these informations, I can find this one's concentration. Concentration comes in what? Moles per decimeter cube. mol dm minus 3. So I can find the concentration. What is the formula to find the concentration, guys? C equals NV. NV remain N over V. Then I said chuttak to make it nice to write N divided by V. I ask you to write like this. So it will be easy for us. So if I write C equals N divided by V, guys, if I write like this, then I can write number of moles I know 0.002 Divide by volume is 250 centimeter cube. To convert to decimeter cube, divide by 1000. Then what will I get? I will get 0.002. Division become multiplication and 1000 goes up. 250 comes down. Then I can simplify 250 and 1000, there are 4. 0.002 into 4 mean I will get 0.008 mol dm minus 3. Again, now I have got the number of moles in 1 liter. Again, you should have more idea what decimeter cube mean liter. 0.008 mol dm minus 3 mean, what does it mean? In 1 liter, there are 0.008 moles. So if I know the number of moles in 1 liter, can't I find how many milligrams are present in 1 liter? What do you mean by ppm? How many milligrams present in 1 liter? If we tell simply, what is ppm? How many milligrams are present in 1 liter? So I can find the number of milligrams present in this. I know the molar mass of this. Okay, molar mass mean what? What is the mass of 1 mole? Then I can find the mass of 0.008 moles. No? What is the formula to find the mass, Puta? Come on, please speak. Simple M equal simple N into capital M. Again, simple N equal simple M over capital M. So capital M I have sent to this side and directly I am writing that as simple M is equal to N into capital M. Then I can write like this. Simple N is how much? 0.008 moles. Capital M is how much? 20 kilo I gave. The normally molar mass unit is 20 grams per mole. 20 grams per mole. So I will get this answer if I multiply like this. Then I will get 0.08, 0.16 gram scale I will get. There are 0.16 grams. 0.16 grams present in this. So this ppm means what? How many milligrams are present? 0.16 gram I can convert to milligrams. No, Puta. How can I convert grams to milligrams? Multiply that by 1000. So if I convert that to milligram, simple m is equal 0.16 multiplied by 1000. So how much I will get, guys? 160 milligram. So what does it mean? Then how many ppm? So this 160 milligram present in how much? 160, right? You can write 160 milligram present, 160 milligram present in 1 decimeter cube solution. Therefore, or hence, ppm is equal to how much? ppm is equal to 160 ppm. So this one's amount is now we have given in ppm. I think now beautiful you can understand about. Again, these are not big deals. Okay, nicely you can work it out. Okay, so you can see how many ppm are present in this. So last week we did if they give the ppm to go for concentration. Today we are giving if you know the moles and the volume, you can go for ppm. Are these things clear? Right. I think next week we will start titration. Titration means we are going to mix things. Next week we are going to mix things. We are going to mix chemicals. I think we'll show videos also. Mixing videos. Right? So when I'm telling mixing videos, I think some people are laughing because they are telling I didn't show them videos, but they are lying. Right? I have shown them lots of videos. Right? Didn't I show you videos? See, Balahang Kiana Vidya. They are telling no Kela. But I showed them these titration videos. Didn't I show titration videos? Right? I showed them. Right? I showed many videos. But Mumbalan. Tagala write this. Tagala write this. Tagala write this. Dang me Viragaran, right? Now say this. Taggala right put the now itself you finish this. Neta ubala liyanna me bala bala. Boru. Last week liyapum pinnand. Ekikkat ne. Oh, yeah. Sure. Last week things. Last week things what you have written last week things. Only last week. Last week you wrote. Last week's night. I'm asking who wrote last week night. No, last week chutti de. Last week we were speaking about baila. Lots of baila. What the baila bang last week? Food. Are poison food gaya hua. मैं बोला बोरू करा नहीं right. तट्टक गाला right पुता. Chutta will do. Chutta will write. But aren't you writing? You don't have a new book. Sad. Are puta, why are you writing in pencil? You also don't have a new book. Okay. Just maintain a separate book for chemical calculation, right? What? Okay. Right. Tattagala write this, puta. Tattagala write beautifully, right? Okay. Okay. Now ppm part is okay. Now I'm going to show you something called half reactions. Something called half reactions. What do you mean by half reactions? Half reaction mean in a complete reaction, a half part, half reaction. Okay. Half reaction mean in a complete reaction, in a half part, I'm going to show. So in half reaction, what is the speciality, guys? You can see electrons in it. Normally in a reaction, you can't see electrons, no. But in a half reaction, you can see electrons. Now we are doing this for first time. Are chutti lamaitane. For A level chutti lamai you all, right? Then A level lokulamai also there, chutti lamai also there. A level lokulamai know this. A level chutti lamai, they don't know this. So we are doing for chutti lamai. So chutti lamai haven't seen electrons in what A levels yet. But they have seen electrons in O level. Can you remember? Chutti lamai is chutti kale. They saw electrons. Right? Can you remember? When did you see electrons? No. Electrons you saw in the reactions in your book you saw, like when you were in OLs. In which lesson? Very good. In electrochemistry you saw, right? Can you remember? You got more confused with that electron. Where to put, how to put, when to put. Right? We'll show everything. How to put, when to put, where to put, everything. Right? Okay. Just imagine this. Now I'm going to show a half reaction. For an example, we'll say how reactions are happening actually. How many people should be there for a reaction? Same person can react to alone. Same person can react alone. You are coming here, you are getting reacted. Right? Him can't. Same person can't react. To do a reaction, we need another person. Then only we can do some reactions. Right? So we need two people minimum. How they do the reaction? When two people are there, one person will give, other person will get. That's the way how they do reaction. Okay, one person will give, other person will get. What are these people giving? Electrons. What's they are giving electrons. One person will give electron, other person will take the electrons. Now there are two people. Careful listen. What did I tell? We'll say there is a person called this person. This is A. What he will do? He will give electrons. He is giving electrons. What is he doing? Giving electrons. Another person is there. Another person is there called B. What this bug is doing? Getting electrons. Nothing a lassana word English we say. Receiving electrons. Receiving electrons. Giving electrons and receiving electrons. Right. So people who are giving electrons, Buddha, we call them these people. They are giving the electrons. We are telling they are going under oxidation. The people who are giving electron, we are telling they are going under what? Oxidation. Again, we are telling they are going oxidation. Here, we'll say A is undergoing oxidation. They are giving electrons. And the person who is getting the electrons, guys, we call them, they are going under, what is happening for them? Right? Again, they are getting the electrons. And we are calling receiving reduction. Very easy word, receiving reduction. Whoever receiving electron, receiving reduction. We call them reduction. Now, Buddha, because of him, no Buddha, this bugger is getting reduction. Therefore, I am calling him as, these words are very important. Hereafter, I'm going to use this. You should be very familiar with this. I'm calling this A person as reducing agent. He's an agent. For what? Reducing. He will reduce others. Reducing agent mean what? He will reduce whom? Others. If we want to reduce others, he should go under reduction oxidation. He should go oxidation and he should reduce others. Because when he gives electron, others will come and take it. Understood? Okay. Tell me what agent should I tell for him? What agent should I call him? Okay. Mozart. Mozart name. What is this? Oxidizing agent. He is what? Oxidizing agent. Again, he will oxidize others. Oxidizing agent. What does it mean? Oxidizing agent mean? What we wrote here? Reduce others. No? So we can write what? Oxidize others. Nice, no? Nice and beautiful. Right. Elakiri. Now we can continue. So reduce others, oxidize others. Right. Puta, for reducing agent, we call another word. For reducing agent's power of this, they have a power, no? This power, again, they have a power, no? Reducing agent, they have a power, no? We are calling this power as, okay, reducibility. Reducing ability. Reducibility. These words are very important. Hereafter, we are going to deal with this. For example, if I say, he is an oxidizing agent, right? Oxidizing agent means then this bug is going under reduction. He's doing oxidation for others. You should come here. Hurry. We'll see. After all these words, now I'll ask questions. It was a balloon. Right? This power is reducibility. This power. This power. This power, what we call? Oxidizability. Oxidizability. Hurry. Right. Now, I hope you can understand everything. Right? Many words sticker more important in this unit 3. Unit 3 name hereafter is what important. Throughout the chemistry, you will find these words. If you don't know the meaning, dead. Put this. More important. I'll explain this with chemicals. At the moment, you just write these things beautifully. If you can use color pens and write these things. Okay, nicely do the work, guys. How many photos we have taken in all this? How many things you? How many screenshots are there? How many screenshots you delete? Still there. Delete. Now delete करवा दे वो वाला नहीं. Delete करना भी कर delete. Yes, keep it. We say please delete. No. That's what we see. अब हम ये. Right. But some gala beautifully right. Okay, you guys also learning something from this. Shut gala, right? Done. Person giving electrons. We'll ask some questions. We'll see how speed you will answer. And this now, so we can hurry the work out on this. Properly work out on this. The person is giving electron. He's doing oxidation. Who is doing oxidation? We are calling him reducing agent. The reducing agent's power is called reducibility. Nikon, I will write certain reactions. They are randomly I will write. We'll say outright reactions later. Now I will show so many reactions. What you have to tell is they are going on the oxidation, the reduction, the killer. You have to take. Done. Done and dusted. Right. Okay, guys. Now let's say they are going under oxidation or reduction. Okay. Now, shut. Okay, I just show how to write the reactions. So it's very easy. For an example, think about magnesium. Magnesium. We'll think about magnesium, right? Magnesium is very beautiful. Okay, magnesium, what is like? Normally metals, they love to give electrons or take electrons. Metals, they love to give electrons. Then mostly magnesium, they don't love to get electrons. They love to give electrons. So magnesium love to give electrons mean normally giving part we are writing in which side, right or left? They're writing the right side. Giving mean we are giving. Now after the arrow only we should write giving. Now magnesium belongs to second group. Group 2, excuse me, Putha, come to this world. Okay, you're thinking about magnesium. I know we have so many memories with magnesium, but still come here. Magnesium, what they will do? Magnesium will, okay, belong to second group. So it loves to give electrons. So magnesium, since it belongs to second group, it will give how many electrons, guys? 2 electrons. So I'm writing magnesium give 2 electrons. So magnesium give 2 electrons mean magnesium become what? Ions now. Why they lost electron? When the people lost electron or when they gain electron, they become ions. The magnesium lost electron mean magnesium become plus ion or minus ion. Losing electron mean their negativity loses. Then they become positive. 2 electrons lost mean they become 2 plus. Remember, Putha, when you write an equation, now everyone can understand how I wrote this. Chutti deyaknu, right? Chutti seen, right? What should happen? So I am telling, okay, here magnesium become magnesium 2 plus by sending 2 electrons. After writing an equation, chemical equation, you have to check both the sides, number of atoms are same. Are the atoms are same? Here also 1 magnesium, here also 1 magnesium. Remember, both left and right charges should be same. This, what is the charge in this side, left side? Speak, Putha. Tell anything. No charge killer, tell. Don't get scared. No charge. What is the charge in right side? 2 plus and 2 electron mean 2 minus. No? 2 plus and 2 minus equal to 0 killer. Since grade 1 we have learned. Right? The charge is how much? 0. Both charges are 0. Very easy. Now what type of reaction is this? Oxidation reaction. Magnesium is who? What agent? Reducing agent. Very good. I'll write for Cl minus. Cl minus is a person who is looking for electron. They love for electron. Right? Non-metals, they love for electron. So Cl minus already, right? Sorry. Cl, chlorine. Chlorine, they love to get electrons. So they will get chlorine's valency is 1. So they will take 1 electron. Getting 1 electron, I am putting a plus. Cl and an electron will join together. And it will form what? Cl minus. Chlorine also having one chlorine, 1 chlorine. This left side also electron mean minus 1 charge. Right side also minus 1 charge. Charges are balanced. Then what we call? When you take electron, what we call for this? Reduction. What is this process? Reduction. So the people who are undergoing reduction, what we call for them? Oxidizing agent. Now Katav understood? Right. Understood that. Now we'll see. We'll say now I am taking 0.05 moles of magnesium. Magnesium I am taking 0.05 moles. 0.05 moles of magnesium. What is the moles produced by magnesium 2 plus? Come on, answer. What is the magnesium 2 plus moles are there? What to think? See the stoichiometry. 1 and 1. This is 1 means this is also 1. So that one also how much? 0.05 moles. Tell me the electron moles. How many electron moles are there? Can you see how many electrons are there? This is 1 mean electrons are 2. Again, for this oxidation reaction, how many electron moles have gone? Electron moles are, you can see, 0.05, like how many times? 2. Then answer is 0.1. Okay, 0.10. 10 means 0.1 moles, right? Can understand both? Very simple. Okay, again, if you can find the electron moles, how much they have got. Very, very simple. Nice, no? Beautiful. No? It's right. Simple. Now you know what is oxidation, you know what is reduction. You can, you know, these are known as what? Half reactions. These are known, this is, we are calling this one as what reaction? Oxidation, half reaction. This one we are calling reduction, half reaction. Okay, reduction, half reaction. Okay, okay. That's it, guys. With this, we are winding up. We'll meet with the next night. Bye. Right. You know, fine. I can. Saraskala, right? Saraskala. Spend 1 minute. Yeah.